Great. And when it comes to movement inside factories and distribution centers, it's a lot of different options. You can use humans, you can use push units, you can use power casters, tow tractors, forklift, a very popular way to transport material. You can also use some other daughter solutions. But today we will focus on the AGV solutions, and we can see it's a very big interest in this type of applications. And we will go through in this webinar why the interest in this application is increasing. We will also discuss benefits and so on. So what do we actually mean when we talk about AGVs? It needs to fulfill some basic requirements. The first one is, of course, that it needs to be self-driving. So it shouldn't be any people involved in the actual driving. You also need some kind of collision warning, which means that the AGV is intelligent, so it can see obstacles or it can feel obstacles, and by doing that it can avoid collisions. If it's an AGV, it also have some type of navigation technique. We will go through that in the webinar, but that is also a requirement for AGV application, that you have some basic approach how to do the navigation. It's also possible to program the path, so you can select different paths and you can also select different destinations. So with other words, it's a machine that can move parts or products from A to B without the involvement of human beings. And we can see that this has very big advantages in the field of logistic systems. And as the requirements are increasing on efficiency, those kind of equipment will be a main player in order to be more and more efficient. Some basic history about AGVs. It's actually not that new invention. The first official AGV was invented in 1953, so it's a pretty long time ago. And it was placed in Esso, their refinery, so they invested in a rebuilt tow tractor. And this tow tractor followed a magnetic induction path that was integrated in the floor, and it towed a number of carts with load on it. So this was the very first AGV application, and it was also known as a guide-o-matic or a no-hands train. So at this point, the name AGV was not invented yet. So this was the first AGV for material transport. And then later on, the AGV was also implemented in assembly operations. That means that you have AGV moving products when they are processed during final assembly. And the first AGV for assembly was implemented at the Volvo plant in Sweden, actually. And at that time, they moved from a traditional mechanical conveyor and assembly line. They moved from that to a more flexible layout with the AGVs, and they had a base. So the workers, they were responsible to build a complete cart instead of just a specific assembly station. And in this project, the AGV was very, very crucial because they could navigate between those different bays in a very flexible way. This was in operation until 94. Then they closed the plant because it was financial crisis and it was not big enough and not efficient enough. And after this time, it hasn't been any AGVs at Volvo for final assembly. And I think at this time it was also a trend that the AGVs the popularity of AGVs kind of disappeared. And it was a lot of reasons for that. But the main reason was that the investments was pretty high. And maybe at that time the technology was not ready. It was too complicated, and it resulted in that the ownership cost, the total cost of ownership for the AGVs was pretty high, and it was difficult to have a good return on invest when you spent this much money. So the trend after this was that the companies more and more invested in more simple technique like chain conveyors, sled conveyors, and so on. That is really mechanical and fixed equipment. But as you all know, there is a lot of change going on, and it's especially a lot of change going on when it comes to technology. And this, of course, has a very big impact on this type of equipment. And this is actually what we can see now, that the AGVs or the self-driving vehicles, they are on the rise again. They are getting more and more popular. They are getting more and more affordable. So for sure, they will have a really big and important place in future factories. And I think you can also see that, you can see some pictures to the right, that this type of technology is also implemented in consumer products. So you all know about the self-driving cars. We also have the self-driving machines that cut your grass in your garden. We also have autonomous housekeepers. And of course, this brings a lot of volume, a lot of knowledge into the same type of technology that is used in industrial AGVs. And of course, this will support to make the industrial AGVs more affordable. And as we see it now, it's a lot of new companies, distributors of AGVs, and it's a really strong trend to develop and make the AGVs more smart and more affordable. It's also a very important part of Industry 4.0. If you have heard about that, it's describing the next revolution that we will have within manufacturing industry and supply chain. So it's a revolution that really will have a big impact in the long future ahead. And we have some examples of similar revolutions that we had. The first revolution was the mechanization. That means that we started with the water power, the steam power, to kind of have this mechanization to start to have the machines. The next big revolution was the mass production. That was the Ford, the assembly line. You split the work content between different assembly stations. That was a very big change for production. And the next big revolution, Industry 3.0, was late in the 60s, where we started to do automation. So that is the PLC softwares, it's the robots, it's all type of equipment that can replace humans, but they are still doing their own work they are working on. They are not collaborating with other machines. So this was a very big step also in automotive, to add a lot of automation and robots and so on. And now we can see the next big step, which then is called Industry 4.0. And this is focusing on cyber physical systems. And that means that we have a very smart, flexible equipment in our factories. And all those factories can communicate with each other. So that is the key here, that we can store a lot of data in the cloud. We have the internet to connect everything. We have the smart equipment. And one of those smart equipment is the autonomous robots, the AGVs. And they will play a major role moving materials, moving parts inside the plants on their own. If they are smart, if they are connected, they can take their own decisions. Where should I pick up the material? What is the smartest way? Should I go here? And so on. It's a lot of smart technology that can be used in order to really focus on the value adding activities. And for sure, we need to find smarter ways of working. This shows the market trends. And I think all of you can recognize these trends. We have a lot of new products, increased number of variants, and that is increasing all the time, and it's kind of developing faster and faster. And in the same way, the total volume for each product and for each variant is decreasing. And another thing is that the life cycle is also decreasing. It's getting shorter. That means that we have change more and more often, and we need to adapt for new products more and more often. So based on this, we will have a really challenge for the logistic concept. In the past, we had few and big industrial supplies. So you had a few part numbers, and maybe you had a pallet full with these part numbers, and it was transported to the assembly line, and you could have it there for a day or 2 days. Now we have more and more frequent replenishments, so you have a lot of different parts. They are presented in kit, and they are really a high pace. You supply the material in every tact. So if you have a car line with you're moving the products every minute, for example, you supply the new parts every minute, so they can be picked just according to that assembly. And we also see a trend that the footprint that is used in the plants more and more is used for logistic operations. In the past, you had the assembly line and most parts were located close to the assembly line. But we see a trend that more and more parts are stored in the preparation area, and that is because you don't have enough space at the assembly line. You need more area to store the parts. So its investigations shows that more than 50% of factories' area are used for logistic activities. And we also see a trend that it will be even higher in the future, that it will almost more look like a warehouse than actually assembly or manufacturing facility, due to the demand from the customer that requires so many different part numbers in the products. And of course, this impact the way we choose to do logistics. And if we can do logistics in a smart way, it will save us a lot of money, as we have this big impact on the footprint. And in that scope, the AGV is a really good enabler to make things more efficient. So we have different markets and different applications for the AGV, and from a flexibility standpoint, it's a really versatile type of equipment. So we see that it's used in automotive, it's used in manufacturing, it's used within pharmacy, also distribution and hospitals. And the type of applications is also very different. We have movement of raw material, for example, coil in a car factory. We move pallets and totes. So that could be that you move parts from the warehouse to the assembly line or a picking area. We can move work in process. That could be a sub-assembly of an engine or sub-assembly of a trim or whatever. But it's some kind of product that are work in process. And as you did see in the beginning, there is also AGVs that moves final products. And of course, when you choose to implement AGVs, you know your own business. So if you know your scope, there are a number of parameters that needs to be considered when you choose what AGV system that are suitable for your needs. And this is showing some major steps in intralogistic projects, and it's very applicable also for implementing AGVs. So it's important to know all the stakeholders, which are the stakeholders that are kind of interested in or need to be involved in the AGV process. What type of AGV? Do we need the cards? What is the supply plan? We call it plan for every part. So each part needs to have a plan. How will we present it to the assembly line? How will we store it in the warehouse and so on? To have a rough plan how to supply each part. The layout is also very crucial to evaluate. The routes, directions, floor quality and so on. It's a lot of parameters that will impact your choice of AGV. And finally, the material presentation. that will make sure that the end customer that receives the material will be happy because the material is presented in a good way. So based on the requirements that you have, there are 5 main categories of AGVs. Of course, there are a lot of customized AGV, but based on the volumes, what is the most common? This is the most common applications. So we have the forklift AGV. It has exactly the same function as a forklift, but it's totally automated. So it can move and lift pallets. Then we have assembly AGV. So that is an AGV used on assembly lines. Normally pretty slow speed. It carries the assembly object and it moves from station to station, either indexing or with a continuous movement. We have the load transfer AGV, where you move pallets on the AGV with the help of rollers. So this is mostly used for pallet transportations. We have the towing AGV, the same as I showed in the beginning from 1953. So that principle tows number of carts, and this is really suitable for long transportations, heavy transportations, and you can take a lot of items or products with you at the same time. And then we have the small load AGVs, and here is where we can see the fastest technology development. This is where we can find the small, flexible, the agile products. So those are used to move light parts, let's say around 100 kilos, and they can maneuver in tight areas. They can move with a very high frequency, a high pace. So this is where we see a lot of new type of products coming in this segment. When it comes to guidance options, of course, this is also historical development, but we have a very basic principle to use magnetic tape that is used for very simple AGVs. In some cases, they are also called automated guided carts. So they are very low intelligence and they follow this magnetic tape that are placed on the floor. We have magnetic spots. So that is, you have some pucks that you place in the floor, and based on those, the AGV can maneuver in different paths. And the advantage with the pucks compared to the tape is that the AGV can choose to take different routes. With the tape, it can only follow one specific route. We have the inductive guidance. So that was the same technology that was used on the first AGV from 1953. You have induction wire milled into the floor. So it requires construction work, and in that way it's not really flexible. So if you want to change the route and so on, it will be pretty high investment to do that. Then we have the laser guidance. You have reflective areas on the walls, and the AGV is building its own map. And with help of those laser guidance, it can maneuver inside your plant. And then what we see more and more, and all new AGVs, they have natural navigation. That means that you don't need any infrastructure at all. They have sensors that can build a map of the environment. And with help of that map, they can navigate on their own. So this is the most flexible way of navigating AGVs, and it's a really low cost alternative, as you don't need to do any infrastructure investments. And when you're implementing AGVs, you need to consider why you're doing the project. For sure, it might have impact on the inventory turnover, so you can have a higher pace of changing the material. You can reduce walking distance for the operators. That is one main benefit with AGVs. Of course, you can also reduce forklifts. And I would say reduction of forklift is one of the main reasons to implement AGVs. Travel distance, you can also reduce area. Maybe when you have AGV, you can have a more narrow forklift aisle. You can have a single one direction routes and so on. So it enables a bit different type of layout. You can reduce number of operators, or you can move operators to a more value-added activities. Accidents, it's more safe. This is more about parts presentation. I think AGV also reduce the number of handlings. So if you imagine the parts from the receiving bay to the end user, you want to reduce the number of handlings as much as possible. And with an AGV, you can achieve a more integrated process. So you add the part on the AGV as early as possible, and it will handle the parts all the way through the plant. And as I said, forklift free, that is one of the main reasons why to go for AGV solution. And I think the statistics speaks for themselves, for itself, and also the function of an AGV or a function of a forklift is mainly the lifting. It's really good at lifting, but it's really not an efficient way to move parts, because you can only move one pallet at a time, and you always need a driver to do it. So that is one thing, and also the safety. So just in US, you have 85 fatal accidents every year, and you have a lot of serious injuries. Of course, this is something that companies are working really hard to reduce, and then the AGV is a key enabler to improve on this area. This is one example from BMW, and I think it's really interesting to see how much money they expect to save by implementing the AGVs. So what they say is that they have worked for a long time with developing the assembly lines, and it seems like they are pretty happy with the performance of those. But they say that the last remaining area is to improve productivity for moving the parts. And in order to do that, they are working with those small autonomous robots to move parts from the warehouse to the assembly lines. And as you can see here, they expect that this activity will cut the cost with 5% per car annually. So it shows that handling parts, logistics is a really big, it's a big part of the total cost when it comes to a product. And companies are really focusing on doing this in a smart and efficient way, because it will have such a big impact on the cost structure. And you see here that the main driver compared to the manual process is shorter response time and improved inventory flows. So this is one of many examples out on the market, and I think this type of applications will explode. We will see a lot of this in the future. And you can also see on this, you can see the sensors, so this is totally navigating on its own without any infrastructure. Some other benefits when it comes to the AGVs. Of course, it can work very hard. It's a hard-working equipment. It can work 24/7. It's cheaper when it comes to operating costs, because you don't need the drivers. And also from an investment perspective, in most cases, it's cheaper than the forklifts. And as I said in the beginning, they are getting more and more intelligent, so they can navigate on their own, they can speak to each other, they can take decisions on their own, they can choose when and how to pick up the part, which route to use to deliver it, in order to really make things in the most efficient way. And one of the main benefits is the flexibility. We know that things change. In all products that FlexQube are involved in, it's a lot of change. You're changing the layout, you're changing the assembly station, you are changing the type of packaging and so on. It's a lot of things going on all the time, and then you need to be flexible, and that is the main advantage with AGV. Also the safety, of course, that is proved a lot You have a predefined routes, you have a continuous speed of the vehicle. If it comes an obstacle, it will stop. So it's a lot of safety features built in that will protect people, but it will also avoid collisions, which in the long term also will save a lot of maintenance cost on the facility its own, because you will not have a lot of damaged racks and damaged gates and so on. As I mentioned before, space efficiency, and it's also a very quiet equipment. When you see them working, they're working really hard, but they are really doing it in a quiet way. It's scalable. You can start in a small scale. If you want to increase the frequency of transports, you just add more AGVs. So it's like it's not any large steps that needs to be taken. You can increase the pace just as much as you want, because it's scalable. And of course, it's easy to integrate with carts. And as FlexQube, we are working with modular carts, and we get a lot of contacts with companies that wants to integrate carts with AGV. And of course, that is the reason why we spend time on learning this area, because we see this as a good service for our customer to also to learn and have knowledge about areas that are connected to our core product, which is the modular carts. So this is something that we work with. And when you integrate carts with AGVs, you can say that it's 4 main principles that you can use. One principle is to attach the top structure directly to the AGV. That is not a cart, but it's still a customized structure that is used to handle a specific part or a specific product. And of course, it's very simple. You don't need any casters, but the disadvantage is that the AGV can only handle that type of load. So the most common is that all AGVs are working together with the carts, because then you can have different carts for different type of loads, different type of applications. And the AGV itself can be exactly the same. And that is a very flexible and modular way of working. So you have one type of integration is the lift. You have the AGV sliding under the cart and then lift it up. You have the mount principle. The cart is going under, or the AGV is going underneath the cart, and you have, for example, a pin that comes up from the AGV to mount it to the cart. Or we have the tow tractor, as we saw in the application from 1953. So this is 4 main ways to integrate that we are working with on FlexQube. And we have examples of all those. So I will show some pictures of this. But first, just some considerations when it comes to layout. This will also affect the performance of the AGVs. So for example, the routes that you choose, do you choose a long route or a short route? Will it affect the battery time? How frequent will you need to do the transports? It's a lot of things to be considered when you decide and design the transport routes. Should you have the routes close to the assembly line? It's a lot of different decisions. The width of the aisles. Normally, if you go for AGVs, you can make them smaller. And of course, that is something that needs to be considered as well if you want aisles only for the AGV, or if you also want to combine for tugger trains or forklifts and so on. The visibility, both for drivers and AGVs. If you choose some type of navigation system, maybe you need a very good visibility in order to see the laser tracking and so on. If you have a total natural navigation, maybe it doesn't matter. But it's something to consider. Travel directions and also floor quality. Some robots, they are traveling pretty fast. It can travel up to 2 meters per second. So in that case, you need to make sure that you have floors that are pretty much with a good quality, because that will give you more efficient transports, and you can move things with a higher speed. The receiving area, of course, you want the receiving area to be as close as possible to where you use the parts, but normally this is decided by the factory layout, so this is not something that you change so often, but in some cases it can be changed, and in that case it needs to be discussed. You have picking areas. You also have, in some case, we have customers that wants to do driving in a hill. Then it's also important to look into the type of AGV, the cart, and so on, so it's applicable for this type of environment. We see increasing need for having carts that can be used both inside and outside, and of course that is also something to consider when you look at the AGV cart integration. Pedestrian areas, forklift areas, drop-off zones. Where will the parts be consumed, and so on? How will they be presented? So this is some areas to consider. Last week we had a webinar about project management, and this is covered more in detail in that presentation material. This is some examples. The lift example. So this car to the left is entering, and then it's lifted up. So the casters are not in the ground during this transport. Then we have the mount principle. So this AGV have a pin. It slides under the cart, and the pin goes up and mount it to the cart. This to the right, that is a cart used for automotive assembly. So it's including all the parts for a seating for a Volvo. So all parts to the seat is kit on this rack. This is the same cart, and here is a picture of the AGV. So it's a pin going up. This is the pin, you can see it in the middle of the white AGV. This is the lift type as well, and one parameter to evaluate when you have the lift function is that if you don't need to move the cart around, you don't need any caster on the cart. So in this case you can see it's only on feet. So the robot is sliding under, lifts the cart and take it to the next destination. This is carts that can be integrated with a towing AGV. And FlexQube, we make carts that are used also for tow tractors, and the type of cart is pretty much the same. The only difference is that the tow AGV is automated, and the manual tow tractor is driven by an operator. But you have different type of tow bars that connects the cart, and the cart is then connected to the tow AGV. And those can be configured in a lot of different variants, different size, different height, different applications, and so on. This shows the different solutions. So this is pallet carts to the left, and we have shelf carts to the right, that all are applicable and possible to integrate with the towing AGV. This is another solution, a mother and daughter solution that can also be towed by AGV. So that was some short examples, and as I said before, the carts are kind of it's a key enabler when you go for AGV project, and a lot of different requirements and parameters will actually end on the cart designer's table. And this is the way that we design the carts. We have the flexible building blocks, and based on those we have a number of steps that we go through in order to design the carts. So it's like simply Lego bricks, and we build different modules and put those together. So we start with the platform, then we add casters, and in some case we add the tow bar. And of course those 3 steps are really integrated with the type of AGV that we choose. So as I showed you before, we have different types. We can lift, we can tow, we can only mount. And based on the decision or the preferred choice of AGV, it will end up in very different solutions here. But thanks to the modularity, it's very easy to change. So, but it's a focus area early in the project. Then when that is fixed, we can start to look into the top structure. Okay, what type of load should we have on this cart? And those together will also affect the layout. So when you've chosen the AGV, chosen the type of cart and so on, that will have impact on the way we can do the layouts. And this is the building blocks that we have in the FlexQube library. So it's 4 main building blocks. It's the flex beam, the blue one. We have the flex plate, the plate on the top here. We have the FlexQube and the flex tube. So those parts are like Lego bricks, and they can be attached to each other in any combination. So if you want to have a FlexQube design created, there is 2 different ways to do it. You have design for all. In that case, you create the design on your own. And the second option is that you participate in a design on demand session, and in that way you integrate with one of our FlexQube designers and you create the cart together with them. And this is the process for design on demand. We ask you to do some preparations, and hopefully you have a pretty clear need of what you want. You have a clear need of the requirements of your cart. You know that, okay, I want AGV, I want to move it like this, I want to transport this type of parts, for example. So that is some basic preparations, and then we discuss this during a meeting, and we do the design in a live session. So you provide the requirements and our designers do the design on time. They do it during the meeting. And in most cases, we can end up with finalizing the cart 80-90% during this 1-hour meeting. So the main target is to clarify all the requirements and have a rough concept that are agreed between you as a customer and FlexQube. So you have a common view of what cart we need. Then we will finalize the design, and we have a target to do this in 1 week, and sometimes we do it a lot faster, and sometimes it requires a little bit more time based on the complexity in the project. But in average, we can make sure that the design is ready within 1 week after we have the meeting. And then we prepare the offer, and that includes a quote, a lot of nice renderings, photorealistic renderings, drawings, product documentation, and so on. So it's a really complete offering with a lot of useful information that you can use internally when you present the solution to your colleagues. Then we have purchase, delivery, and maybe the first round you make a prototype. So then you do some evaluation. And then if you have some feedback, we start over again. You prepare and we have a short meeting, and then we will continue with this process. So it's a standardized process, and we have used it for a while, and the result so far is really, really good. If you want to do the design on your own, there is different options. We have CAD files for Solid Edge, SolidWorks, CATIA, Inventor. We also have InStep if you want to use another CAD software. And we have started to use Onshape, which is the new generation of CAD, where everything is based in the cloud. So this is really also part of the Industry 4.0. All the CAD files, all the information is stored in the cloud, and the actual design of the cart is made in the web browser. So it's a very short startup time. I will talk a little bit more about this later. It's here actually. So design with Onshape means that you are doing the design in a web browser. No installations at all. It's very easy to sign up, and this is what we like about this, is that we really want the FlexQube concept to be available for everyone. So all our CAD files are available in this system. And it also works together with iPad. You can share IDs with colleagues. You just share a link and they open it and they will have the file open in their web browser. So it's a really seamless, this is really the future way of designing carts. And if you are interested in training, we offer training sessions free of charge. So if you want to try and do your own designs to get started in Onshape or any other software, you can contact design@flexcube.com and we will get back to you with a training. So finally, I just wanted to summarize a little bit about the FlexQube concept. I've given you a rough introduction to AGVs, a history, different types, different user applications, and so on. And one of the main benefits with the FlexQube concept is that it's a really platform-independent concept. Thanks to the building blocks, we can do solutions for any type of platforms. If you choose to go for the AGV, you can choose to go for a tugger train, or you can choose to just move the cart manually, but independent of the platform you need, we will be able to do it because we have the modular building blocks. And one advantage is that if you want, you can actually do the design on your own. It's not very difficult, and it's, to be honest, it's pretty fun. And we will spend a lot of energy to simplify even more for customers that want to do their design on their own. So we will launch a pretty big package soon with a lot of more tools, more tutorials, more material to support people that choose to do their own designs. We have design on demand, and we are really proud of that. It's a unique for the business. We can create designs on the fly, and you can have a quote, a design proposal, CAD files, and everything within a very short time. And we see that as a really enabler. It's a modular concept, enables us to do things different compared to, for example, welded concepts. We work globally. And that is very important for us because we have a standardized concept, and standardized concepts are made to work globally. If you have a plant in Europe and you want to use the same solution in US or in Brazil or in Asia, it should be the same solution, same way of distribution and so on. So it's a standard that are available globally. We work together with a lot of different customers, and if you want to discuss different projects, to have different ideas and so on, you're also welcome to contact us. We have a wide base of knowledge from different areas: automotive, energy, food industry, and so on. So we see a lot of creative ideas every day that customers come up with. Appearance, for some it's not important at all, but we think that the appearance and the design of the FlexQube carts, we think they look pretty good. And I believe that in the future the design of industrial products will be more and more important. Of course, the function is the main reason why you buy industrial products, but the look and the appearance will be more and more important. It's a very good replacement for welded carts, and that was the idea with the FlexQube concept from the beginning, to replace welded carts. Delivery options. You can choose to have carts assembled, but you can also choose to buy the carts in bits and pieces. And by doing that, it will be a very efficient way of doing the transports. Yeah, I mentioned this, the standardized. We have our Lego bricks, our standard building blocks, and everything is based on this. It's easy to repair. It's like repairing a Lego model. If something breaks, you can just replace that part that is broken. You don't need to repair. If you have a welded cart, for example, it's very hard to repair. You need to replace the complete product. Then we have the documentation. We continuously improve, but we have really high ambitions to provide really good documentation to our customers. So when we have finalized a design, we provide 3D models, we provide drawings with measurements, we provide key shots, renderings that is photorealistic. We also provide product documentation, with the risk analysis. What is the risk of this car? What to think about? What is the maintenance? So we take this very seriously, and it's also an area where we want to be even better, and we want to make the information very accessible. So documentation is something that is we are really good at, and we will do it even better. Then when it comes to integration, one type of integration is of course the AGV, but as I said in the beginning, we can integrate with any type of product, and we can also integrate with similar type of concepts to build the cars. For example, Trilogic or Freeform. It's very popular concept out there, and it's sometimes good for different applications, and we also see a possibility to integrate with those type of concepts. So even if you choose to go for a FlexQube solution, it can also be integrated with other type of products. It's important for us to be flexible and to really enable different ways for the customer. So that was a summary of FlexQube, and I hope that you have learned some more about automated guided vehicles. For sure, it will be a part of the future. We see increasing number of manufacturers, increasing number of cases. Prices are getting more realistic, and they are easier to install, implement, and so on. So for sure, it will be a part of the future. Next webinar will be the 24th of November. That is about future logistics. And then I will talk more about Industry 4.0. I will talk about future trends within intralogistics. So that will be really in the forefront, conceptual. What do we think will be in the factors in the future? So that will be a very exciting webinar. So I recommend you to join that one. So that's all for today. I will stay online if you have some questions regarding this. Otherwise, thank you very much for attending, and I wish you a good day. Thank you. Okay, no questions, so I will leave the meeting. Thank you very much for attending. Have a good day. Bye-bye.